Here is something nobody tells you when you start learning Rust. You can write code that compiles perfectly, passes all your tests, and works in development, and still be doing Rust completely wrong. Not wrong in the sense of bugs, wrong in the sense of fighting the language instead of working with it. Wrong in the sense of making your code harder to read, slower than it should be, more fragile than it needs to be. I have reviewed a lot of Rust code over the past few years, in pull requests, on GitHub, from developers who reached out for freelance help. And there are specific patterns I see come up over and over again. Not beginner mistakes like missing a semicolon. Patterns that experienced developers from Python, Java, and C++ bring into Rust because they made sense in the other language, but hurt you here. In this video I am going to take you through 10 of the most common ones, with the wrong way, the right way, and a clear explanation of why it matters. If you recognize yourself in any of these, do not worry. Every Rust developer has made all of them. The goal is to stop making them going forward. Let's go. Before we dive in, I want to talk about Aarambh Dev Hub's partner, CodeCrafters, and this one I actually mean it when I say it is a good one. If you have been watching Aarambh Dev Hub for a while, you already know that we are all about understanding how things actually work under the hood. Not just using tools, but truly understanding them. Why does Redis work the way it does? How does Git actually store your commits? What is really happening when you type a command in your shell? CodeCrafters is built around exactly that same curiosity. CodeCrafters is a platform where you rebuild real developer tools from scratch. Things like Git, Redis, a shell, an HTTP server, a DNS server, a BitTorrent client, you actually build them yourself, stage by stage, in your own language. Every stage unlocks the next, and you can see exactly how far along you are as you go. Now the most popular language on CodeCrafters is Rust, and that makes total sense for this channel. If you're just getting started with Rust and want to learn it the right way, this is honestly one of the best approaches out there. Instead of reading theory or doing small exercises that go nowhere, you sit down and build something real. Something you have actually heard of. Something that exists in the real world. And that is when Rust really starts to click. This is not your typical tutorial platform where you just watch someone else code and feel like you learned something. You are the one writing the code, you are the one debugging it, you are the one making it pass each stage. That kind of active, hands-on learning is what actually makes you a better systems programmer, and I will be honest. It is genuinely a lot of fun. The challenges are used by engineers at companies like Google, Meta, and Shopify. And if your company has a learning and development budget, there is a very good chance CodeCrafters is covered under it, meaning it could cost you absolutely nothing out of pocket. Worth checking with your manager before you pay yourself. The link is in the description below. Check it out, and if you do sign up through it, you also directly support Aarambh Dev Hub, so thank you in advance if you do. Alright, now let us get into the video. The first mistake is something almost every Rust developer starts with. Using unwrap and expect everywhere. Here is the wrong way. Every one of those unwrap calls is a potential panic waiting to happen. If the file does not exist, your program crashes. If the JSON is malformed, your program crashes. If the key is missing, your program crashes. And the error message is confusing. Called unwrap on a none value, tells you nothing about which operation failed or why. Here is the right way. The question mark operator propagates errors up automatically. The with context and context calls from anyhow attach meaningful messages. If something fails, your caller gets a full error chain telling them exactly what went wrong and where. This is the difference between a tool that's debuggable at 3 a.m. and one that is not. The rule is simple. In production code, unwrap is only acceptable for things that genuinely cannot fail, creating a regex from a hard-coded pattern, parsing a literal string. Everything else gets the question mark operator. The second mistake is reaching for clone every time the borrow checker complains. Wrong way. Every clone allocates new memory on the heap, copies the bytes, and then the copy gets dropped at the end of print name. You are doing work for no reason. Right way. When a function only reads data and does not need to own it, take a reference. For strings, an str is almost always what you want as a parameter type. It accepts both string references and string literals. For other types, an t is usually right. Only take ownership when you actually need to store the value or modify it. Cloning is sometimes correct, when you genuinely need two independent copies of data. But if you are cloning to satisfy the borrow checker without understanding why, that is a signal to stop and think about whether ownership is the right model for that function. Quick break. If you are recognizing these patterns in your own code, hit the like button. It helps this reach more Rust developers who need to see this. Subscribe for more content like this every week. Back to the mistakes. Closely related to the previous one. Using string as a parameter type when ASTTR is better. Wrong way. Right way. The impl into pattern is the idiomatic Rust way to accept anything that can become a string. String literals, string values, cow, all work without the caller having to think about it. The conversion happens inside the function exactly once. For read-only access you use ancestor. For stored values you use string. For constructor parameters you use impl into. These three use cases cover almost everything. The fourth mistake is writing C-style for loops when Rust's iterator methods produce cleaner, often faster code. Wrong way. Right way. This is not just style. The iterator version is often faster because the compiler can apply more aggressive optimizations. It can vectorize the loop. It knows there are no bounds checks needed on iterator methods, and it can sometimes eliminate the intermediate allocations entirely. The index-based version cannot get those optimizations because the compiler has to be conservative. And the readability difference is real. Filter, map, sum, you read what the code does in English. With the index loop you have to read every line carefully to understand the intent. The fifth mistake is reaching for ArcMutexT every time you need shared state, even when you do not need it. Wrong way in an AXM app. If your config never changes after startup and your counter is only ever incremented, you are using the wrong tools. Right way. Mutex means only one thread can access the data at a time, readers block other readers. RwLock allows multiple simultaneous readers and only locks for writes. Atomic U64 for counters and flags needs no lock at all, the CPU handles it with a single hardware instruction. For data that never changes after startup, Arc with no lock is the right answer. Wrapping immutable data in a mutex adds locking overhead for no safety benefit. This one is dangerous. It is one of the most common sources of deadlocks in async Rust. Wrong way. This one is dangerous. It is one of the most common sources of deadlocks in async Rust. Wrong way. When you hold a std sync mutex guard across an await point, the mutex is locked during the entire sleep. Any other async task trying to acquire the same lock will block, not yield, it will block the entire async thread. In a busy service, this can deadlock your whole application. Right way. Option 1, drop the guard before awaiting. Right way. Option 2, use Tokyo's async mutex. The Tokyo sync mutex is designed to be held across await points. It yields to the executor instead of blocking. But the simplest fix is almost always to do your work under the lock, store the result in a local variable, drop the guard, and then do your async work. The seventh mistake is not running Clippy or ignoring its warnings. Clippy is not just a style checker. It catches real bugs and performance issues that the compiler does not. Here are 3 things Clippy catches that matter. First, unnecessary collect and iter pattern. Second, using len equals 0 instead of is empty. Third, manual range contains. Run cargo Clippy, all targets, D warnings in your CI pipeline. Treat every Clippy warning as an error. The warnings are right more often than you think, and fixing them makes your code faster and more idiomatic at the same time. If you are working through these patterns and want to discuss Rust best practices with other developers, come join the Discord community, the link is in the description. We run a weekly Sunday study group and this kind of deep Rust discussion happens regularly. Link is below. Right way. These are called Newtype wrappers. They are zero cost, the compiler strips them at runtime, so age 25 costs exactly the same as a plain U32. But at compile time, they are completely different types. You cannot accidentally pass an account ID where an age is expected. This pattern is one of Rust's most powerful tools for making invalid states unrepresentable. Use it for user IDs, Product IDs, currency values, percentages, any domain concept that happens to be stored as a primitive but should be treated as distinct from other primitives of the same type. A small one, but it shows up everywhere. The plus operator for string concatenation in Rust is more confusing than in other languages because of ownership rules. The first operand must be an owned string, while subsequent ones must be references. It leads to strange-looking code with ampersands all over the place. Format handles everything: string slices, integers, floats, any type that implements display. Use it for any string that involves more than one piece of data. The 10th mistake is the deepest one. When the borrow checker refuses to compile your code, the instinct is to fight it. Add clones, wrap everything in Arc and Mutex, use unsafe. Often the right move is to restructure your data. Wrong way, the code you are trying to write. The compiler rejects this because if users is reallocated when you push to it, the active user reference would be pointing at freed memory. The borrow checker is saving you from a use after free bug. Wrong fix, fighting the compiler. Right fix, redesign using an index. Instead of storing a reference into a collection, which is impossible without unsafe, store the index. The reference is computed on demand from the index. This is valid, safe, zero cost, and clean. When the borrow checker stops you, ask first, does this data structure actually need to store a reference? Usually the answer is no. Store an index, a key, or an ID instead. The compiler is rarely wrong. It is usually pointing at a design that needs to change. Before the outro, if this channel has helped your Rust code genuinely improve and you want to support the work, you can buy me a coffee. The link is in the description. Every supporter makes it possible to keep making these videos. Thank you genuinely to everyone who already has. Those are the 10 Rust mistakes I see most often. Unwrap everywhere, cloning instead of borrowing, string instead of str, index loops instead of iterators, mutex instead of RwLock or atomics, holding a mutex across an await, ignoring Clippy, not using newtypes, string concatenation with plus, and fighting the borrow checker instead of redesigning. If you recognize yourself in more than 3 of these, do not worry. That just means you are learning. The goal is not to be perfect. The goal is to keep improving. Hit the like button if this helped. It genuinely helps this video reach more Rust developers. Subscribe for more Rust content every week. Drop a comment below. Which of these mistakes have you made? I read every single one. Check out the REST API video, the CLI tool build, and the Axum vs Actix benchmarks for more production Rust patterns. All linked in the description. Join the Discord community. We discuss exactly these kinds of patterns in the weekly study group. Link in the description, and support via Buy Me a Coffee if you want to keep this content coming. Link is also there. Thanks for watching and happy coding.